On this first one, I want to caution you because I saw a lot of you using 4 as your perfect square. The problem is if you think about 8, 4 also goes into it. So like if you did this, you would get 2 radical 8, but then you'd have to go through the process again because 8 could be written as 4 times 2. That's why we want to find the biggest perfect square, because otherwise we have to do it more than once. So 4, remember I said 4 goes into 32, but it also went into 8. So 4 times 4, 16 is the biggest perfect square that goes into this. So we rewrite 32 as a product of 16 times 2 because we learned the past couple days that there's a property of square roots that says you're allowed to split this product into 2 parts. And then since this part is a perfect square, the square root of 16 is just 4, we want to take the square root of it. Square root of 2 is not whole, right? That's why you leave that part in radical form. So 4 times radical 2 is equal to this. It's just a simplified version of it, okay? Now on this one, we took one product and split it up into 2 different products, right? This next question, you're doing the opposite of that. You're going to write it as one product, 2 times 50, and 2 times 50 is 100, but then the square root of 100 is just 10. So that one comes out nice because 100 is a perfect square. Okay, and then we've been learning that in math, we're not allowed to write answers with a radical in the denominator. So we learned a process to get rid of that radical, which is called rationalizing the denominator. And in this type of problem, to rationalize the denominator, you have to multiply by, again, what's called the conjugate of this, which just means 5 plus radical 11. And you have to do it to the numerator and the denominator. Okay, so yesterday I had told you you may want to add parentheses around this to help you remember that you're going to have to multiply negative 6 times 5 and times radical 11. So negative 6 times 5 would give us negative 30. Guys, you may want to throw a 1 in here for yourself because you need to understand the negative 6 is getting multiplied to the 1 to get negative 6. Like you can't multiply it to the 11's inside a radical. So you can only multiply numbers if they're both in a radical or they're both not. So you just write negative 6 times radical 11. Down in the denominator, again, you maybe want to add some more parentheses because we said this is a FOIL problem. Like you have to do 5 times 5 to give you 25. Outer 5 times, again, maybe you want to put a 1 here. 5 times 1 radical 11 is 5 radical 11. And then again, maybe you want to do it there too. It's like doing 5 times negative 1. So negative 5 radical 11. And then the last, negative 1 times 1 is negative 1, but it's radical 11 times 11. This time, since both of them are in a radical, you can multiply them. So you can just write 121. So again, some of you from doing several problems on your homework last night may have gotten used to the fact, again, that these middle terms are always going to cancel. Oh, my board's a little bit behind. The middle terms are always going to cancel. So, because they're opposites, they add up to 0. So you're just going to have 25 minus, this is a perfect square. The square root of 121 is just 11, right? That's the goal, to get rid of the square root. We're trying to form perfect squares. So then in the denominator, 25 minus 11 is just going to give us 14. So then remember, 2 things you have to check here to know whether this is your final answer or not. One of those things would be to look at this number right here, the radical 11. You would have to check if that can be simplified using the process that we learned, that we did back on number 1, right? When we simplified. But it can't be because the only factors of 11 are 1 times 11. But then the other thing you would need to check is like, can both of these be divided by something? But you'd have to look at it this way too. So essentially, all 3 of the numbers would have to be able to be divided by the same number in order to simplify. It's the same thing as simplifying fractions, but they all can be divided by 2. So negative 30 divided by 2 is negative 15. Negative 6 divided by 2 is negative 3. You wouldn't do anything with the radical part, you're just only looking at the non-radical parts. 14 divided by 2 is 7. So we just have to remember to simplify the non-radical parts then too, okay? All right, moving into today's lesson, we're going to be solving quadratic equations by taking square roots. Now, we've already learned how to solve some quadratic equations by factoring. Like, if we had something like, let me think about this for a second. I got to work backwards real quick. If we had something that looked like this, we had learned how to rewrite this in factored form so that we could figure out what the solutions are. Like, remember how we looked at, like, x could be 5 because 5 minus 5 is 0, or x could be negative 2 because negative 2 plus 2 is 0. So today, we're not going to have to take the equation and rewrite it in factored form. The reason we had to do that previously is when there's an x squared term and an x in it, you're going to rewrite it in factored form, okay? The equations we're going to look at today, like, take a look at this. Do you see how it only has an x squared in it? It doesn't have an x in it. So we're not going to have to go through the steps of factoring. We're going to be able to use just like basic skills that you learned back in Algebra 1 to try to get this x alone. Like, we're going to work backwards and get rid of, like, the 5, for example, until the x is alone. So I'm going to write PEMDAS up here for a second because we're actually going to be thinking about the steps going backwards. Like, this equation, if you look at it, doesn't have any addition or subtraction in it, so just skip it. But multiplication division is next, and since this says 5 times x squared, if we're working backwards, we want to do the opposite. Because 5 divided by 5 is 1, right? It's going to get us a step closer to x being alone. 80 divided by 5 is 16. So we're done with that. Then exponents, but again, we're doing opposites. Like, we're trying to get this alone, which means we want to get rid of that exponent. So you're going to do the opposite of square. You're going to take the square root because it would cancel it out and x would be alone. That's what we want. We're trying to get x alone or solve it. So here's the only thing you have to be careful of. So you may know the square root of 16 is 4. It's a perfect square. You've been working with that a lot the past couple days. So the past couple days when we had the square root of 16, we just wrote 4. But now that it's an equation, we have to think about the fact that it could also be negative 4, because I want you to think back to this step for a second. If I fill in 4 here, 4 squared means 4 times 4, which is 16. But if I fill in negative 4 here, negative 4 squared also means negative 4 times negative 4, which is also 16. So when you're solving equations, there's now going to be 2 possible answers that you could have because of the fact that 4 times 4 is 16, but negative 4 times negative 4 is also 16 if we were to, like, plug in our answer and check it, okay? Let's do another one kind of like that so you get the hang of it. This one has addition subtraction this time. So when you start to work backwards, the first thing you're going to want to do is add 7 because we're trying to get rid of it on this side, right? Negative 7 plus 7 is 0. On the right side, 29 plus 7 is 36. And then again, to get z alone, you're going to have to get rid of the square, which means do the opposite. Take the square root. Now, again, yesterday we just wrote the square root of 36 is 6, but because it's an equation today, you have to tell that it could also be negative 6, because if you check your work and fill in negative 6 here, negative 6 squared means negative 6 times negative 6, which is positive 36, right? So the answer will not just be 6, it could also be negative 6. Guys, side note real quickly, when you're doing your edge elastic, it's going to give you 2 different boxes. So, like, our answers of 4 and negative 4, you're just going to write them separately, okay? Or on this one, our answers of 6 and negative 6, you're just going to write them separately. And it's going to ask you to type the smaller answer in the first blank. That's why I wrote negative 6 first, okay? Questions so far at all? So we're going to do one more similar to that, again, because there's only an x squared in this. Some of the things we've looked at already had an x squared and an x, and those we solve by factoring. Here we can simply solve it just by working backwards till the x is alone. But the order that you work backwards in matters. Like every second of your life that you're in math class, you have to be thinking about PEMDAS, okay? So if we're going to work backwards till this x is alone, we're going to be doing PEMDAS in reverse, okay? So the first thing we will do, get rid of the 6, because you're going to take care of addition or subtraction first. 6 minus 6 is 0. So it would leave me with 4x squared. 150 minus 6 is 144. Then we're done with this, so keep going backwards. So again, like we can't jump and take this square root next. You're not following order of operations if you do that. You got to get rid of the 4. Opposite of multiplication, we would do to get rid of it, right? Because 4 divided by 4 is 1. Make sure you do the same on the other side so you keep the equation balanced. Then, now that that's done, we can go on and take the square root. Once again, because the square root and the square are opposites, they cancel. We got x alone. Yay, that's what we wanted, right? But once again, you have to remember, even if you plug this square root of 36 in your calculator is only going to tell you 6. So you have to remember on your own that it can also be -6, because again, if we want to check our answer, let's talk about the check real quick on this one. If I write out this equation, I'm going to write it like this for a second, okay? If I were to fill in 6, 6 squared is 36. But if I were to fill in -6, -6 times -6 is also 36, right? So then this would look like this at this point, like 36. And then you could do 36 times 4 and add 6, and guess what? You're going to get 150. It's going to check out. But again, this is why the answer can be 6 or -6, because of this step right here. 6 times 6 is 36, but -6 times -6 is also 36, okay? So we would have to tell both solutions. X could be -6 or x could be +6. All right, we're going to take it one step further, okay? So far on every question that I've given you, the number that we were taking the square root of was a perfect square. So it came out to be a nice whole number, 6, and it's opposite, okay? The next one we're going to look at, the first couple steps are going to be the same still. So let's go ahead and start this the same way we did the last couple. We're trying to solve for x, so we're trying to work backwards till x is alone. So again, we're thinking about PEMDAS in reverse, which means we want to do addition or subtraction first. The reason we take away 5 is so we can get rid of it on this side and get closer to x being alone. 41 minus 5 is going to give us 36. That's done. Again, don't try to take the square root next. Keep going backwards. We got to do multiplication or division first. In this case, that means division, because 3 divided by 3 cancels that, right? Make sure you do the same thing on the other side. So we're going to now take the square root just like we did on the other ones. But again, that gets a little complicated, because go to your calculator. The square root of 12 is not a whole number. It's going to be some ugly decimal. Back in Algebra 1, you would have just given that ugly decimal as an answer. But we don't do that anymore in Algebra 2, because we've now learned how to take this and simplify it. Okay, so over off to the side here, when I say simplify that, that's that process we learned a couple days ago where we need to find a perfect square that goes into 12. And hopefully you know, because you've seen 12 a couple of times, hopefully you know 4 is the perfect square that goes into 12. So like we're going to rewrite 12 as 4 times 3 so that we can split it up and actually take the square root of this part to just get 2, okay? So we're going to, first of all, at this point where we take the square root, remember we have to put positive or negative, just like on the last one, the answer could be +6 or -6. We still have to do that here. Every time you take the square root, the answer could be positive or negative. It's just that we're not going to write an ugly decimal. We're going to write the simplified radical answer, okay? So again, if this were edge elastic, it's going to give you 2 boxes because the answer could be 2 radical 3, or it could be negative 2 radical 3. You're always going to have 2 answers when you solve an equation by taking the square root, okay? And again, edge elastic's probably going to ask you to type this one first because it's going to ask you to type the smaller answer first, which would be the negative one, okay? Questions so far at all? All right, you go ahead and do like the first couple steps of this one on your own. Hopefully you're ready to go on. Again, guys, when you're trying to solve for a variable, it matters what order you do things in. Like, we always want to be thinking about PEMDAS when we're in math class, always. If we're going backwards, we're going to start with addition or subtraction. So you should have added 50 to both sides, since negative 50 plus 50 is 0. It gets us a step closer to that A being alone. This is going to give us 162. Keep working backwards. This is next. Opposite of multiplication. Since we're trying to get A alone, we want to get rid of the 32. We want to divide by it. So that'll just be A squared. 162 divided by 32. If we do that in our calculator, it's going to give us a decimal. I want you to go ahead and math frac it. I'm going to show you that. It's just like what I'm saying. You just hit the math button and select frac, the first thing in the list. So we're going to leave it as 81 over 16. And then again, this is done. Now opposite of square, if we take the square root, it would cancel the square and get A alone. When we take the square root on this side, we got to remember to put this symbol right away, because whenever you take the square root of something, we have to remember the negative times a negative would give us this back again. Okay, now here we're going to think about the property we learned yesterday and write this as 2 separate things. And then this one's really nice because both of the things are perfect squares. Like the square root of 81 is just 9 and the square root of 16 is just 4. It's not always going to be so nice. Sometimes you might have numbers that aren't perfect squares, and then that's going to make more work for us, okay? But the 2 answers, again, would be, if this were edge elastic, we would type negative 9 over 4 for one and positive 9 over 4 for the other. And again, guys, if it were a test or quiz, I would get used to filling in my answer here. You could even type this all right in your calculator, but I would make sure it equals 112. And then when you fill in the negative version, since a negative squared is positive, you're still going to get 112 that way too, okay? Questions so far? All right, let's see what happens on this one. We'll do the first step together. Again, if the goal is to solve the equation, the goal is to get P alone. There's no addition or subtraction, so we move right on to multiplication division. Get rid of this 4, right? Opposite of multiplication, divide by it. 448 divided by 4 is going to give us 112. We're going to go on to exponents. We're trying to get rid of a square, which means you have to undo it. You have to do the opposite. So square root of 112, go ahead and punch that in your calculator, and you should see an ugly decimal because 112 is not a perfect square. Remember what we learned earlier? We don't want an ugly decimal. So off to the side here, I want you to ask yourself, how do I simplify 112? Like, how do I write it as a product of 2 things? One of the things needs to be a perfect square, right? You're using that process we learned. Again, guys, be careful that you find the biggest one. It's not 4, because then it would be 4 times 28, but 28, 4 can still go into it. Like, if it has another perfect square in it, then 4 is not the biggest one. You should have picked 16. So 16 times 7. So then remember, we can split it apart so that we can take the square root of the part that's a perfect square to get a nice whole number. Okay, so again, I do that off to the side because all we're trying to do is change this to be more simplified. And now we know that the more simplified version is 4 radical 7. Okay, So again, we don't give decimal answers at all. We write everything in what we call simplest radical form. One more time, if this were edge elastic, my answers would be positive 4 radical 7 and negative 4 radical 7. We got to remember that there's always going to be 2, because if we plugged it in to check it, a positive squared is positive, but so is a negative. They're both going to work if we plug it in to check it, okay? All right, next equation we're going to look at, go ahead and get it copied into your notes. We're still going to be trying to get x alone. The goal is to solve it, which means get x alone. But it looks a little different because there's a quantity. We haven't had any with parentheses so far. But the first couple steps are still going to be the same, because if we're working backwards, the parentheses are going to be dealt with last. Like, we're not going to worry about that at all right now. We're going to handle addition or subtraction first, which means get rid of this negative 36. So add it to both sides. Let's show what will be left on this side. 0 plus 36 is 36. Keep working backwards. Guys, never try to distribute this. You can't do that when there's an exponent right here, okay? That's why instead we have to go backwards and divide by it. We can't multiply it into the quantity, so we have to get rid of it. 36 divided by 4 is 9. We're done with that. Guys, the next step, again, keep working backwards. We need to get rid of the exponent, so we're going to take the square root. Don't get confused, because there's this big thing here. This opposite of square is still a square root. So all you would be left with here is the x plus 2. You don't really need parentheses around it now that it's the only thing left. Take the square to this side too. Guys, I purposely gave you for the first one here a perfect square. So this will come out nice, 3. But again, you have to remember it can be negative 3, because 3 times 3 equals 9, but negative 3 times negative 3 also gets you back to 9 again, right? Whenever you take this square root, you have to put that symbol, okay? Now, the thing that's weird about this one is the last couple questions, taking the square root was the last step, right? This time, that's not our last step, because x isn't alone yet. We have to get rid of this 2. So we would take it away. Okay, now you could just recopy this. Like, you could write positive or negative 3 minus 2, but I would actually flip it around and put the negative 2 first. Okay, so like all I did was flip the order. Okay, the reason I would prefer to write it like that is to get your 2 answers. What you're going to do is negative 2 plus 3. Like, just read this from right to left. Negative 2 plus 3, which is 1. But then you're going to do negative 2 minus 3 also. So that's negative 5. So these will be my 2 answers this time. Again, notice every other problem we did so far, the answers were just opposites of each other. That doesn't happen in this one, because the opposites happen back on this step. And then we still had another step after that. So again, guys, I just want to stress checking your answer. Why 1 would work and negative 5. Think about filling in 1. 1 plus 2 is 3, but 3 squared is 9. Whereas if you do negative 5 in place of here, negative 5 plus 2 is negative 3. But guess what? Negative 3 squared is still 9. And then if you go on, since we got 9 in the parentheses, you could go on and do 4 times 9, 36. And guess what? 36 minus 36 is 0. Okay? So both of them are going to work if you plug it in to check it. Okay? Those ones are a little bit harder when there's a quantity involved in it. So we're going to walk through one more of those together just so you get the hang of it. But why don't you go ahead and start to do just maybe the first 2 steps? Like, look back at the example we just did together and see if you can do just the first 2 steps for me. Now, again, the goal is still to get x alone, because that's what we do when we're solving an equation. We're trying to find the value of x. So we're going to work backwards in PEMDAS. So make sure you handle addition or subtraction first. That doesn't mean right here, because that's inside a quantity. You can't touch that. This is what we want to handle right here. Get rid of the negative 18, add it to cancel it out. Okay, we get 28 over here. Keep moving backwards, multiplication or division. Again, we can't multiply this in here because of the exponent, so we need to do the opposite. We need to divide it out, get rid of it. So you're going to have x plus 4 squared equals 4. Again, I purposely made this a perfect square this time so that when we keep working backwards, which means take the square root next because that's the opposite of square, this is going to come out whole, right? Next time, that's not going to happen, which is going to make it just a little bit harder. But again, you have to remember that it could also be -2, right? Because at this step, -2 times -2 would get me back to 4 again, right? So then once you get to this step, again, we're not done because x isn't alone. We got to get rid of this 4. So you're going to write x equals, again, you could copy this in the order that it's written, positive or -2 minus 4, but I would always flip it around and put the -4 first, then your symbol and 2, because to get what the two answers are, it's still like a math problem. Like you got to do -4 plus 2. So -2 is going to be one answer, but then you got to do -4 minus 2. So -6 is going to be your other answer. Again, you could go plug those things in and check them, and it would work. Questions on that at all? Okay, again, we're going to look at one next where when we get to this step, this guy is not going to be a perfect square. So this is in the form of a standardized test question, and there's multiple choice. But guys, you shouldn't even look at the choices. You should take your equation and just write it out and start by doing all of the steps that we've been learning. So if we think about PEMDAS, we would handle addition or subtraction first, but there isn't any except in here, but we can't do anything with that when it's in parentheses like that. So we're going to get rid of this guy. So opposite of multiplication, guys, you could divide by 1/5, but that gets kind of sloppy. You may remember from Algebra 1 that multiplying by the reciprocal, 5/1, which is just 5, that's much easier. It's much easier to do 7 times 5 than 7 divided by 1/5. That's sloppy, okay? So we're done with that. So far, nothing different than the last two questions, except when we move on to exponents, which means do the opposite, so you can cancel it, take the square root. The square root of 35 is not whole. Check it on your calculator if you need to. You'll get an ugly decimal. We're not going to we are going to go ahead and do this, right? Because no matter what the answer is, we have to remember the opposite will also work. But we're not going to write an ugly decimal. We have to ask ourselves, can this be simplified at all? Like, is there some perfect square we could write this as? But there's not, because the only factors of 35 besides 1 times 35 are 5 times 7, but neither one of those are a perfect square. So we're just going to leave it right like this since it can't be simplified, okay? And then again, z is not alone yet, so you got to take away 3. So here's how you're going to write your answer, just like the other ones. Remember I told you, let's go ahead and write the -3 first, and then the plus minus symbol, and then radical 35. So again, on the last one, this was a whole number. So that made it easier because we could actually do this math. We could do -4 plus 2 or -4 minus 2. Here, all you're going to do to write your answer, your two answers, is you're just going to write -3 plus radical 35. Like, you're not going to actually do it because remember how radical 35 was an ugly decimal? We don't want ugly decimals in our answer. And then just -3 minus radical 35. We're doing what we call this leaving it in radical form because we don't want to give a gross decimal, okay? Again, on Edge Elastic, it's going to ask you to type your smaller answer first. That would be this, because if you take away something, you're going to be like further into the negatives. That would be smaller than if we do -3 plus radical 35. Okay. All right. Last one. This is going to be the most complicated one. You'll see why in a second. The first step is the same, though. We start working backwards. There's no addition or subtraction except in here, but that doesn't count because it's inside the parentheses. We're not up there yet. We're going to do multiplication division, which means get rid of the 3, right? Don't try to multiply it in there. We can't do that. We got to get rid of it. Instead, we got to divide by it. Go to your calculator and type in 40 divided by 3 and see what happens. It's a gross decimal. I want you to math frac it. In other words, leave it as 40 over 3. Okay? We're done with this. Next step is exponents. So we're trying to get rid of the exponent. So we're going to do the opposite. We're going to take the square root. So when we do it on this side, we're going to make sure we put positive or negative. And then I want you to think about this guy off to the side, like radical 40 over 3. We're going to think about it over here for a second. I'm going to write it like this instead. Remember, we learned that property that when it's division, you can write it as 2 separate radicals. So really, I'm going to write it like that for a second. The problem is we can't leave our answer like that because remember how it's illegal to have a radical in the denominator? So we got to rationalize this thing here. Okay, so we have to think about the steps we just learned yesterday. You're going to have to multiply this by radical 3 over radical 3. So let's look at our numerator. Radical 40 times radical 3, just write it as one product, but like, again, 40 times 3 is just 120. Like, you can actually multiply it together. Same thing in the denominator. We're not going to write, we could write it as one product, but just go ahead and actually do the math. 3 times 3 is 9, so that makes it radical 9. But the square root of 9 is just 3, right? Remember, that's good. That's the whole goal. We were trying to get rid of it and have it be a whole number. No radicals allowed. So this, again, is so many steps because guess what? This guy doesn't come out whole. You can check it in your calculator. It's not a perfect square, but you can simplify it, though. So we got to think about radical 120. What perfect square goes into it? Go ahead and think about that for a second. I didn't tell you. It's just 4. 4 is the only perfect square that goes into it because 4 times 30, if you think about 30, like there's no more perfect squares that go into it. So remember, that way we can write it like this so that we can go ahead and take the square root of that. Okay? So this is the simplified version of this guy, okay? So we're going to go ahead and change this thing. Instead of having this, we're going to put that simplified thing that we found, 2 radical 30 over 3, okay? I know this is a lot, so I hope you're taking all these step-by-step notes. There's still one more thing. X isn't alone. We got to add 2 to get rid of it. Okay, just like the other ones. Remember I told you I would rewrite it so that this part comes second. Like I would put the 2 first, then your plus or minus 2 radical 30 over 3. So that means if we were going to write our 2 solutions on Edge Elastic, you're just going to say 2 plus this gross fraction, but we don't want a decimal. We have to leave it in radical form. You're not going to put decimals on any answer on your homework today. And then 2 minus that crazy fraction. Okay? Again, on Edge Elastic, this is the one you would type first because it would be smaller. 2 minus something that's going to put you to a lower number than 2 plus the something. Okay?